at the small scale, which means the nano scale, and so it is the most candidate to be a gateway to science, technology, engineering, and mathematics field. So I always prefer to start my presentations by mentioning the talk of physics Richard Feynman at 1959. The title of this talk was "There's Plenty of Room at the Bottom." In that time, nanoscience and nanotechnology wasn't so known, and there was no developments at this field. But Richard Feynman imagined and believed that if we control materials at small scales, at the atomic and molecular scales, it could be a revolution, technological revolution, or evolution in medical applications also. Some of his sayings, for example, he said that why can't we write the entire 24 volumes of Encyclopedia Britannica on the head of a pin, and consider the possibility that we too can make it in very small that does what we want, and so on. Richard Feynman believed that small-scale materials would be the influence for scientific and technological revolution. In that talk, Feynman never explicitly mentioned the idea of nanotechnology, but nowadays we know that he meant the nanoscience and nanotechnology. So when we talk about nanotechnology or nanoscience, it's a science that deals with materials, structures, devices, everything that is at the nanoscale. That's 1 billionth of a meter. Nanometer is 1 billionth of the meter. And I always to my students, if I want to explain or highlight what does that mean nanoscale, we just take the ruler and we look at the closest lines in the ruler that is equal to 1 millimeter. We have to divide it 1 million times in order to get 1 nanometer. So why it's so important for materials at the nanoscale? Because the properties of materials, we could say about physical properties and also chemical properties at the nanoscale change. It could be changed dramatically. So it reflects the applications of these materials. The applications switch off on very different sides just because we minimize the size to the nanoscale. Nowadays, we are in several applications of nanomaterials and nanosystems, medically and technologically. And the very important feature of this that is interdisciplinary, multidisciplinary science field that it combines chemistry, biology, physics, material science, and also engineering. So nowadays, nanotechnology has its fingerprints on various fields, and so it is scientists from all over the world believe that we have to intensify vocational training programs among undergraduates, future students, and also even pupils from the elementary school, because all the nanotechnology applications are reflect our modern daily life. So we have to be in parallel when teaching science, in parallel with all the developments in science. But there's a problem. As Gilbert said in 2006, that over the decade, science education has faced many challenges. Overloaded curricula, isolated facts, low engagement, and lack of relevance. And this means, in one side, this makes nanoscience education a big challenge. But in the other side, this may be a solution because nanoscience and nanotechnology are very relevant to our daily life. So it could also solve some of the problems in teaching science. So for this purpose, there is some of my publications from previous study about developing lab experiments, activities, and strategies that aim to highlight to undergraduates and high school students. And my existing research is talk about teaching chemistry in context with nano, which is a gateway to STEM field, because according to the previous studies, nanotechnology applications represent relevant contexts that can make science more relevant, more interesting and meaningful to students' lives and their daily experience. And learning science in the context of nanotechnology applications provides students with the opportunity to learn how science works and the role of science and technology in finding solutions in everyday life problems. So, goes to the traditional teaching approach for 9th grade students' learning achievements and their interest motivation to study science fields. We choose the main topics that are taught according to the teaching curriculum. For example, here I got 2 examples of main topics that are taught in 9th grade, which is types of solutions and allotropic structures of materials, and we developed a new models that include in that we teach these subjects in context or by integration of aspects and concepts of nanoscience and nanotechnology. Research questions, the main research questions, how does teaching chemistry in context with NST affect students' interest and motivation to learn chemistry, and how does teaching chemistry in context with NST affect students' achievements in chemistry. Participants, as I said, are 9th grade students from classes in a high school in North Israel, from the Arab sector in Israel, which are national minority, tied by language, culture, identity, history, collective memory, and narratives. Education system is managed by Israeli educational system, and the education system in Israel is based on democratic and Western values and encourage open discussion and opinions. Research process. The research was carried out using the vast experimental setup and includes a control group and experimental. We have 3 stages: pre-intervention, the intervention phase, and post-intervention. And at the beginning of the study, 6-hour seminar session was conducted with the participant teachers to introduce the basic concepts and aspects about NST, its correlation with teaching materials, its impact on our modern daily life, and finally the development of teaching model on types. For example, on types of solutions and allotropic structures of materials. And in each developed model consists of 9 lessons. For each subject, we developed a teaching model. The duration of each lesson is 45 minutes, and it incorporates different teaching strategies from frontal lessons, hand-on activities, lab experiments. That relation to daily life has a very significant part when teaching these subjects. And here in this slide, I just wanted to highlight what's that mean. How could we integrate nanoscience and nanotechnology aspects when teaching basic subjects in chemistry? For example, we have here 2 solutions. The first one is food color solutions, red food color solutions. The second one is a solution of nanostructures of coal, pure coal. It's also a red, but it's are different solutions. Its microscopic structure is very different, and the application of these solutions are very different. The solution of coal nanoparticles could be used for medical sensors, could be used for different medical applications, for drug delivery, and we can give an example here that the home test for coronavirus was based on this great solution of all nanoparticles. So nanoscience or nanomaterials are exist in our daily life. So our students must be aware of this. When we talk about a lot of structures of materials, we have to mention the carbon nanotubes. We have to mention the extreme properties of carbon nanotubes and its uses. Its uses, in, for example, as a channels for biosensors, this is the next generation for drug delivery, and its high electrical conductivity, which is greater than the electrical conductivity, for example, than of aluminium. So it is used in electrical devices, and nowadays it is very used in electrical devices, and also by teaching the anatomic structures of materials. We could also mention the nanoparticles of gold, which is also structures of pure gold, but its uses or its properties are different from the familiar properties of macro scale gold that we know. So mention the main and principal results. This research proved that the teaching chemistry, or you can say teaching science, because nanoscience and nanotechnology is part of biology, physics, and chemistry, engineering. So you can teach every field of this science by integration with nanoscience and nanotechnology to prove that it raised the motivation for learning chemistry, and the research, the statistical analysis proved that there's a strong correlation between the motivation for learning science and the students' achievements. And here we also we have the results for every component of the every component of the motivational survey was researched and explored separately. And also, as I said, that the students' achievements has higher for the experimental group after the intervention in comparison with the control group. And as a conclusion and discussion, the existing curriculum in chemistry is loaded with many important subjects. There is great difficulty in adding modern content to it. Added to this are the challenges faced by chemistry teachers in teaching the subject, which originate from students' perceptions of subject as difficult, irrelevant, and disconnected from daily life. As a result, the students develop negative attitude toward the profession, low motivation, study, and in their achievements in the profession are low. But the question is, what is the effective approach in teaching chemistry? One that will make chemistry more relevant and meaningful for students, and as a result will have educational contribution for them. The question will try to answer in this current study through the teaching of chemistry in context with nanotechnology, which is a modern science that penetrates many areas of life, including the field of education, a multidisciplinary science field known to have relevance and connections to the students' daily lives. Therefore, based on the assumption that the integration of nanotechnology in the teaching of chemistry may help to improve the students' motivation to learn the subject as well as their achievements in the subject. And finally, I want to present my last book that was published by the Royal Society of Chemistry. This book includes firstly a scientific introduction on nanoscience and nanotechnology that is benefit for teachers, for undergraduates, for high school students that they have no idea about nanoscience and nanotechnology. And also after that, different teaching strategies, teaching modes, lab activities, and class activities that aim to highlight or teach aspects and concepts of nanotechnology for students from elementary school to undergraduate. Thank you for